In this video, we'll learn how to use scientific notation. When using scientific notation, there are a few rules that apply. Scientific notation is written in the form of a times 10 to the nth, where a is greater than or equal to 1, but less than 10, and n is an integer. When multiplying by a positive power of 10 will result in a number that is larger than a. When multiplying by a negative power of 10 will result in a number that is smaller than a. So in our example below, we see 12.0 times 10 to the third. Since 12 is bigger than 10, this is not the proper way to write in scientific notation. Instead, we would write this value as 1.2 times 10 to the fourth. In scientific notation, we are essentially just multiplying a number by a power of 10. When you multiply a positive power of 10, the result is greater than the original number. The exponent determines how many places to the right that the decimal place should be moved. So if we have 3.4 times 10 to the third, it's the same thing as saying we have 3.4 times 1,000. When we multiply a number by a negative power of 10, the result is a smaller number than the original number, and the exponent determines how many places to the left the decimal point is moved. So 4.7 times 10 to the negative third power is the same as saying 4.7 times 0.001. To convert a numerical value into scientific notation, first we must take the numerical value and locate the decimal point. We can see that the decimal point is at the end of the last zero. Then we see if we move the decimal point and put it between the 5 and the 7 will satisfy this property of scientific notation. Once our decimal point is moved, then we can count the number of places between the original and final decimal place. Then use the number of spaces as the exponent of 10. So we moved our decimal point from behind the last zero to in between 5 and 7. There are 4 integers. So our exponent is times 10 to the fourth. So now let's try to apply this and convert our numerical values into scientific notation. So we see here that we have our decimal place at the end of the zero, and we're going to move it between the 4 and the 3. If we do so, it'll give us 4.35 times 10 to the fifth. Since we have 1, 2, 3, 4, 5 integers between the original and final place of our decimal. If we do the same thing for our next example, if we move the decimal to in between our 4 and a 5, we can write our scientific notation as 4.58 times 10 to the negative third, since we moved it 3 places to the right. For our last example, we have 243.4. If we move our decimal places 2 places to the left, it'll give us 2.434 times 10 to the second power. Now let's try to convert scientific notation back into its numerical value. So we see that's raised to the fifth power, so we're going to move our decimal place 5 places to the right. If we do so, we'll get a value of 760,000. For our next example, we see our value is 2.9 times 10 to the third. If we notice our exponent is a negative, we'll see that we're going to move our decimal places 3 decimal places to the left. If we do so, we'll get 0.0029. And finally, we have 6.75 times 10 to the second power. Since it's a positive power, we're going to move our decimal place 2 places to the right. And when we do so, it'll give us 675. When we perform operations with numbers in scientific notation, it's helpful to remember the rules of exponents to perform these operations. In our first example, we have negative 2 times 10 to the third power multiplied by 4 times 10 to the fourth power. We see that both our numbers are written in scientific notation. So when we multiply our two values together, we can separate our 2 and our 4 from our powers of 10. When we do so, we see that this will look like 2 times 4 multiplied by 10 to the third power times 10 to the fourth power. And so we can multiply our 2 times 4, which will give us a value of 8. And if we carry our negative sign through, we'll have negative 8. And then if we look at 10 to the third power multiplied by 10 to the fourth power, we can add our exponents, which will then add up to times 10 to the seventh power. In our second example, we have 3 times 10 to the third power divided by 4 times 10 to the fifth power. So once again, our values are written in scientific notation, and we can separate our 3 and our 4 from our powers of 10. So when we do so, we see we would have 3 divided by 4 multiplied by 10 to the third power divided by 10 to the fifth power. So when we divide 3 by 4, we get a value of 0.75. And when we take the division of 10 to the third power divided by 10 to the fifth power, we'll subtract our exponents to get times 10 to the power of 3 minus 5, which will give us a value of 0.75 times 10 to the negative second power. And in order for us to write this in correct scientific notation, we'll have to move our decimal place one more to the right. And so when we do so, we see that our number written out in scientific notation will be 7.5 times 10 to the negative third power.